what tells you that this is linear? When you look at this, what tells you that you know it's linear? It has a slope, yes, because what's the invisible variable, or invisible exponent here? 1, so it's first degree, which gives a slope. Nice job. So if it's a degree 1, it's always going to be linear, so it's invisible 1, okay? So let's take a look at it. So I'm going to go ahead and I'm just going to plug in. I'm going to plug in 0. Let me use my calculator, okay? Plug in 0, plug in 10, I'll plug in 20. Plugging in 0 is easy, right? I'll just show you, but you know it. 0.000 times 0 plus 10, most likely it's going to be 10. Yeah, I thought so. 10. I'll plug 10 into it, so this is my temperature. So I'll go 0.0001 times 10 plus 10. 10.001, right? Plug in 20.000 times 20. Oops, 1. My bad. 1. Oh, I forgot the 1 in there. Oh, that's terrible. I got to rewrite that one too, Brittany. I have to have the 1 there. Times 20 plus. I made another mistake, huh? 10.02. And then this would be 10.003 and then 10.004, okay? Wow, I got to fix that. Darn it, I hate making mistakes. So graph this function. Well, all right, let's see here. How am I going to do this? I got to use my brains. I go 10, 20, 30, 40, and 50, right? And this is going to be very strange because how are you going to graph these? Well, what I'm going to do is start at 10 and go a big squishy. I'll go 10.001, 10.002, 10.003, and a 10.004. Okay, so I don't want to change the scales in between, but I can squish all of this up to 10, okay? So I compressed the graph. From 0 to 10 has been compressed because I went by, well, thousandths, right? And so then I'd have a point here, a point here, a point here, and I'd have a point there, okay? Okay, how am I doing? Can I connect the dots? Yeah, I can connect the dots because there are temperatures in between, right? And you got a 5 degree temperature, you got a 6 degree temperature, so I can connect the dots, okay? Okay, here's a really interesting question. Can I extend the graph back here? No, because you can't have negative lengths, right? I mean, it's 10. It's not going to be less than 10. So what's a reasonable domain? Well, domain is the x values, right? So domain is going to be the temperatures. And we can say it's between 0 and 40, according to this. Okay, that's 40 degrees centigrade. That's pretty warm. That would be my domain. Domain's this. And I didn't go to 50 because I wasn't given any information on the 50. And then the range has a length of 10 to about 10.004. If it gets hotter than 40,
we could adjust. 40 degrees Celsius is pretty darn warm. It really is. Thank you, Brittany. Okay, you guys ready to turn the page? So that's linear. It's linear, it's a function, it's a straight line. You can't have two different lengths at any particular. I mean, think about this. It's a railroad track. How can there be two different lengths at the same at one time? Impossible, right? Impossible. You can't have two different lengths. Okay. All right. Here we go. The senior class. Class gas. Oh my goodness. Senior class. What the heck? Senior class has. Should be has.
Fix your paper.
Wow, I got some work to do, don't I? Okay.
Spot.
Yeah, did you find that one too? Thanks.
On the camera.
Oh, thank you, Brittany. The senior class has gas. No, I didn't say that. Has rented an ice rink to raise money. They will charge $5 admission, but the rink will cost $200. Okay. So write a linear equation. So we could go right. Y equals. I'm not. But I don't want to use Y. I want to use income. Okay. Income. I don't want Y. I want income. Okay. Income with respect to the number of tickets. Okay. I mean, this has nothing to do with Y and X. This has to do with income, right? So I used I and N for the number of tickets, right? So they're going to charge $5 per ticket, but if we don't sell any tickets, we're automatically $200 in the hole, right?
So the y-intercept thing.
Right. Okay, so let's go ahead and see if we can graph this. I totally agree with you, Kai. Let's see, I'm going to try and graph this. Let's go my XY axis here. Okay. Okay. How many kids are going to come to our ice rink? What do you guys think? How many kids can maybe get into that, huh? 70? Okay, you guys are good at 70? Yeah, okay, so we got about 70 kids. So we'll hopefully sell 70 tickets. Okay? Because it says, what's a reasonable domain range? Well, okay, 70 tickets, okay. So if we don't sell any tickets, we're in trouble, right? But our domain is the number of tickets starting at 0, okay? So our domain, what's the least amount of tickets we sell? 0, right? And what's the most amount of tickets we could sell? 70, right? Yeah. Maybe 100, but Kai wanted to say we're full at 70, okay? What about our range? Our range is our Y value, right? So if we don't sell any tickets, what's our income? Negative 200, right? You put 0 in here. Plus, if you don't sell any tickets, you're going to lose money. So negative 200. And if we sell all 70, what's that? 140. Hold on. 5 times 70 minus 200. We make $150. Ooh, we got to sell more than 70 tickets, Kai. That's pretty sad. Right, Carly?
We do not have 70 in our class.
Well, but maybe we're going to invite some of the underclassmen, huh? Because we're not going to make any money, right? We're not going to make any money. But we'll keep going with this, right?
Wait, are we talking about a general senior class or our senior class?
Well, we want to generate some income. We want to make some money.
You know what?
That's a start.
You're more than they do.
I don't know, Carly. How many tickets can we sell? We're going to have to erase, though.
No, 70's fine.
Okay, 75. So we'll make 100.
It can be,
We'll make $150 and have fun, okay?
Yeah.
Okay, now here's an easy way to graph this. All you need is 2 points, right? I mean, we can do all our scales a little bit. We could, all you need is 2 points, right? So I'm going to have to go to negative 200. So I probably need to shift up, and I can go by 25. So I'm going to move my x-axis up. I have to write about, maybe right about there, okay? There's my x-axis or my n-axis, okay? Let's go to negative 200. So if I go by 25, 50, 75, 100, 1, 2, 3, 4. I'm all the way down here. Okay. And then 150 at 70. So maybe I'll make these go by 10s, right? 10, 20, 30, 40, 50, 60, 70. And I go 150, right? So I went 25, 50, 75. There's 100. Here's my 175. And then I've got a point right up here, okay? And if I connect the dots, I'm good. All right. So what's my break-even point? It's right there, isn't it? Let me go ahead and highlight it. My break-even point is right there, okay? It's also called a zero, right? So we don't make any money. We don't lose any money, but we don't make any money. So how could we find that point? It looks like it's 10, 20, 30, 40. I'm not sure, but we could set this equation equal to 0, right? We make 0 money, break even. 5n minus 200, right? I mean, right here, we don't make any money, so our value is 0. So just set the income equal to 0, plus 200, divide, and I should get 40, right? So if we can sell 40 tickets, we break even, right? Well, how many tickets must they sell to make 400? We just set it equal to 400, right? Which means we're probably going to let more people in, Carly, than 70, right? You know, we're just going to have to let the juniors come in, hang out with us, right? But the juniors are pretty cool, so maybe the sophomores. But you're like no freshmen, huh? Why not?
We'll invite the super seniors.
Okay, we'll have a few of those around. Okay, so we set it equal to 400 because that's an income, right? And we'll solve, right? That's my income. And let's solve. So plus 200, I'll get 600 equals 5n. Divide by 5, what's that, 12? 120? 120. So I get 120 tickets. Okay. Now, what if the rink can only host 240 people? Well,
That's fine, because we only have 70.
I know, so that changes our range and domain, doesn't it? But I had you guys pick it. I thought that'd be fun to have you guys pick it. Okay, so if I income, I have 240, right, is equal to 5 times 240 minus 200. Okay, I'm just plugging into the equation, right? And then I'm just going to use my calculator. I believe in calculus, I do. And I get about $1,000. How's that? Much better. Okay. So, homework again, page 22. 1, 3, 5, 6, 7, 10, 11, 13. Once you get a book, you'll understand why I give the odds. Because I don't mind you checking